In this lecture, we'll explore the concept of abstraction in Python. We'll talk about what abstraction is in object-oriented programming, why it's useful, and how it helps us simplify code by focusing on essential functionality while hiding implementation details. Then, we'll use a real-world analogy to explain the idea further. We'll move on to abstract classes and methods, learning how they define blueprints for subclasses. After that, we'll explore Python's ABC module to implement abstract classes, followed by a real-world example of a payment system to see how abstraction works in practice. We'll also introduce abstract properties and how they enforce structure across subclasses. Finally, we'll wrap up by discussing best practices for using abstraction effectively. By the end of this lecture, you'll have a solid understanding of how to use abstraction to create structured and maintainable code. Abstraction is one of the key principles of object-oriented programming. It allows us to hide the implementation details of our code and only expose the essential functionality. Think of it as focusing on what an object can do, rather than how it does it. Abstraction is essential because it enables us to create reusable components that can be used in different parts of the program without needing to know their inner workings. It helps keep the code base simple, easy to maintain, and free from unnecessary complexity. Let's take a moment to consider an everyday example: driving a car. When we drive, we don't need to know how the engine works or how the transmission engages. We only care about pressing the gas pedal to move forward or the brake pedal to stop the car. This is an example of abstraction in action. We only interact with the essential features while the details are hidden. In Python, abstraction is achieved through abstract classes and methods. An abstract class is a class that cannot be instantiated and usually contains one or more abstract methods. These methods don't have an implementation in the abstract class. Instead, subclasses must provide the implementation. We create an abstract class when we want to define a common interface that different subclasses must follow. Abstract methods serve as blueprints that guide subclasses. Python provides the ABC module to create abstract base classes, or ABCs. The ABC class and the abstract method decorator help us define abstract classes and methods. Let's see how we can create an abstract class in Python. I'll create a new file for this practice and name it paymentsystem.py. First, we import the necessary modules. From the ABC module, we import the ABC class as well as the abstract method decorator. Now, let's create a simple abstract class for a payment system. The ABC class is used to define abstract base classes, and the abstract method decorator is used to declare methods that must be implemented by any subclass. So, payment is an abstract class, and process payment is an abstract method. Notice that the method doesn't have any implementation. Subclasses must provide their own version of this method. Let's check and verify that we can't instantiate an abstract class like the payment class. If we run the script, we'll get a type error saying that we can't instantiate abstract class payment without an implementation for abstract method process payment. To make things more concrete, let's build a real-world example around a payment system. We'll create different payment methods by subclassing the abstract payment class. Here, both PayPal and credit card are subclasses of payment. Each provides its own implementation of the process payment method, which was defined as an abstract method in the parent class. In the PayPal class, the process payment method prints a message that indicates a PayPal payment is being processed for the given amount. Similarly, the credit card class overrides the same method but prints a message indicating a payment through a credit card for the specified amount. These concrete implementations of the abstract method allow the subclasses to handle payments in their own specific ways while maintaining a consistent interface defined by the payment class. After defining the PayPal and credit card classes, we can now create instances of them. Let's create an instance of the PayPal class and invoke its process payment method to process a payment of $100. If we comment out this problematic line and then run the code, we'll see the message, processing PayPal payment of $100, which shows that the method from the PayPal class has been called. If we replace PayPal with credit card, we're now creating an instance of the credit card class instead. If we run again, this time the method in the credit card class will be called and the output will be processing credit card payment of $100. This demonstrates how we can use the same method across different subclasses, but the behavior changes based on the specific subclass we're working with. This is an example of polymorphism in action, which we will discuss in more detail in a separate lecture. We can also use abstraction for properties. This is useful when we want subclasses to provide their own implementation of certain properties. Let's create an abstract property using property and abstract method decorators. Here, we added an abstract property called currency, which is defined using the property decorator combined with the abstract method decorator. As we learned earlier, the property decorator allows us to define a method that can be accessed like an attribute. By combining it with abstract method, we're saying that any class that inherits from payment must implement the currency property. However, there's no implementation provided in the payment class itself, meaning that the subclasses must define what the currency will be. In other words, this abstract property enforces that every subclass of payment must provide its own implementation of the currency attribute. For example, in the PayPal class, we define the currency as USD. Whereas in the credit card class, it can be something else like CAD. Now that each subclass has its own currency property, let's use it in the process payment method to show the specific currency for each payment method. In the process payment of the PayPal class, I'll replace dollars with self.currency. Then I'll do the same for the credit card class. Let's try creating instances of both subclasses to see how they work. Now, when we run the script, each subclass will display its payment details along with the appropriate currency. So by using the currency property in the process payment method, each payment method can specify the currency in which it operates. Abstraction helps enforce that certain methods are implemented, ensuring that the structure of our code stays consistent. It also improves reusability and maintainability since we only need to define the essential functionality in the abstract class, while details can vary in the subclasses. While abstraction is powerful, we should avoid overusing it. Too much abstraction can make our code unnecessarily complex. It's best to use abstract classes when we want to enforce a particular structure or when we expect subclasses to implement specific methods. To summarize, in this lecture, we've covered what abstraction is and how it's used in Python. We looked at abstract classes, the ABC module, and saw how abstraction allows us to enforce a method structure while hiding unnecessary details. We also worked through a real-world payment system example. We discussed the advantages of abstraction, including code reusability and enforcing structure, and touched on best practices for using abstraction effectively.